Hi guys, this video is about proving if each triangle is a right triangle. It's called the converse. So please label converse at the top of this section of your foldable. We've already done hypotenuse, leg, and now we should be in the middle to the left over here. Make sure you have a pencil, 2 colors, and a calculator. Okay, so what we do here is prove. Okay, we prove if it's a right triangle. Okay, so by looking here, I'm going to go ahead and do my understanding of a right triangle and find my legs. I know that these are my legs for 2 reasons. They make the straight angle of a right angle. So this is my A and this is my B. But I also know that these 2 numbers are smaller than my 10. So now I'm going to go ahead and notice that this is my C. And when you prove if it's a right triangle, you're checking to see if it's going to equal in your Pythagorean theorem. Like this. Write out your formula that we already know. Draw your line down and substitute for each letter. So my A is square root of 50. And then I have to square that. My B is the square root of 50 as well. And I have to square that. Does this all equal to my square root or to my C? And my 10 is C. So then I'm writing 10 squared. So now I go ahead and I start solving. Square root of 50 squared, remember, those cancel and just becomes 50. So then I have 50 plus another cancel, another 50. And then does this equal what 10 squared is? 10 squared is 10 times 10. That's 100. 50 plus 50 is 100. So on both sides, I need 100 equals 100 for my answer to be yes. This is a right triangle. My work has to prove it. So my substitution is really important, and also finding which are the legs to equal your hypotenuse. Let's go to the next one. This one's shaped a little bit easier. I have my legs making that straight angle, 90-degree angle. Also, this is my A. And this could be my B. And this has to be my C because it's the biggest number for the longest side. Because it's the biggest number out of 10, 10.5, and now 12.5 is the biggest. So I'm going to go ahead with my formula and substitute. A is 10.5, so 10.5 squared plus my B, which is 10 squared, and then my 12.5 is my C, so I'll write 12.5 squared. Now I need to check what is 10.5 times 10.5, or 10.5 squared, 110.25. 110.25 plus 10 squared, we've already memorized those squares of 10 times 10 is 100. And then 12.5 squared. I don't know that. 12.5 squared. 156.25. 156.25. Okay. Now I have to check. Do these two numbers add up to 156.25? So I'm going to go ahead and write 100.25 plus 100. I'm going to line up 0.00 because that's how you write your decimals when you don't have anything after the decimal. 100. So I wouldn't put my 100 over to the right. It has to be lined up with the 110. So then this is 0.25, and then 0 plus 0, 1 plus 0, 1 plus 1 is 2. So here I have 210.25 equaling 156.25. These are not equal. They are not the same on both sides here. So my answer is no. This is not a right triangle, and my work has to prove it. Okay? Let's do the last one. All right. It looks like my legs are straight here and then straight down. I also know that the square root of 13 is in between 9 and 16, so it's like 3 or 4. So 4 has to be my longest side. Again, you could always use a decimal or a calculator to check if you're not sure. So square root of 13. That's 3.6. So then I know that these can be my legs. This is my A, this is my B, and then this has to be my C, because this is 3.6 something. So 4 is the biggest, which means it's my hypotenuse. So I'll go ahead and sub everything in. My A is the square root of 3, so now I square that. My B is the square root of 13, and I have to square that. And then equals C squared, which is 4, so I write 4 squared. Now when I cancel, that's because I see square root being squared, so they cancel each other out, and you're left with just 3. Same with the 13, square root and square gets canceled, 13. Equals in the middle. 4 squared means 4 times 4, 16. Now I add it. 3 plus 13, 14, 15, 16. Does that equal 16? Yes. They should be equal on both sides. This is a right triangle. So there is my proof. That is called the converse, proving if it's a right triangle. So you get all 3 side lengths all together, and then make sure that it's equal on both sides by checking your work. So now you have almost the whole foldable done, but the insides, the next video will be about the graphs. Thanks, guys.